Hello, I am Dr. Papia Bhattacharjee. In this problem, we have two equations that are given to us, and we have to find the points of intersection of the graphs represented by these equations. So how do we calculate points of intersection of two graphs? Just quickly note that if we do have a graph, say a function f1 and say a function f2, and they're intersecting at a point, what is happening there? See, for this x value, whatever it is, both graphs will have the exact same y value. That's what happens. So for one x, they have the same y, right? So what can we do? We can consider this first equation, let's call it y1, and the second one, let's call it y2. And then to find the points of intersection, remember the two y values should be equal, so we just have to set y1 equals y2. So points of intersection can be computed by setting the two y's equal to each other. And what will that give us? Well, if we set y1 equals y2, we just take the expression for each one and set them equal to each other. So we have negative x squared plus 15 will be equal to 3x plus 11. And notice that now we have an equation in x, and we have to solve for x. And that should give us the points that we intend to find. All right, so how do we solve? The best way to do it is bring all the expression on one side of the equation and set it equal to 0. So let's try that. We have negative x squared plus 15 on the left. Now bring the 3x on the left side as negative 3x and the 11 on the left as negative 11, and set everything equal to 0. Now let's simplify this expression if we can. So we have negative x squared, negative 3x, and the two constants can be combined together. 15 minus 11 is plus 4, and that is equal to 0. Now notice that this is a quadratic equation. We can factor, but before you factor, remember usually we make our x squared free of any sign, and now x squared has a negative sign. So let's make it positive so it will be easier to factor. And how do we do that? We just distribute a negative sign throughout. So we have x squared will be positive, the negative of the 3x will become a positive, and the positive sign for 4 will become negative. Now we have a pretty good form, and we can try to factor. So let's see. We have a negative 4 here that you have to split, and then when you add, you get 3. So how do we do that? You have to have positive 3. So let's make it plus 4 and minus 1. So 4 times 1 plus 4 times minus 1 is minus 4, and 4x minus x will give you a 3x. So that looks like correct factor. Now, each of these factors, they're linear, and each factor will give us an x value. So from the first one, we have x plus 4, set it equal to 0, and that will give us x equals negative 4. And the second factor is x minus 1, set that equal to 0, that will give us x equals 1. So it seems like we have two x values when we set the equations equal to each other. But remember, this is not our answer. We have to find the points of intersection. So you have to find the corresponding y value so that we can write it as a point. So here is our x. How do we calculate the y? Well, remember the concept. Both equations should give us the same y. So it doesn't matter which of these equations you choose, plug in the x value in one of them, and then you get your corresponding y. So I'm going to choose my second equation. Since it's linear, it'll be easier to compute anyway. So let's choose our y2, 3x plus 11, and you plug in x equals -4, so you get 3 times -4 plus 11, which is -12 plus 11, and that is -1. So from this first set, you get your point -4, -1. That is one point of intersection. Now we have another one, another x value. You can again choose either one of the equations. I will choose y2 and plug in x equals 1. So it will be 3 times 1 plus 11, which is 3 plus 11, and that is 14. So our second point is 1, 14. So we have 2 points of intersection for the graphs of these 2 equations. Finally, to complete this problem, we have to check our answer using a graphing utility. So you pick whatever graphing utility you have, and then let's find the point of intersection of the 2 graphs. So the first thing you should do is plot these 2 functions. So write down in your y1, write down the first equation, -x² plus 15, and then go to y2 and write down the second equation, 3x plus 11. All right, and then plot both of them in the same window. Now, to choose your window, just be careful. You should be able to see both points. So you should get an idea how to choose the window from the points itself. See, the x minimum you can do from -5 and then go up to 5. And then y, the max value of y should be greater than 14, as you can see. So let's choose between -10 and say 20. And then graph them. And look, you see there are 2 curves. One of them is a parabola. Now, of course, the first graph should be a parabola. And the second one is a line because it's linear. And they do intersect at 2 points. So how do we check if the points are correct? So go to trace and then just plug in the x value. So x equals -4. And look, the y is -1, and it is showing that that point is the point of intersection. Let's check the second one. Plug in x equals 1 and enter, and you get y equals 14, and it is showing that that's the other point of intersection of the 2 graphs. So this confirms that we have found the correct points of intersection for these 2 graphs. Thank you.